Hello. Let us start with exercise 18A of limits. Okay. Exercise number 18A. Question number one. Okay. So if you refer the question, they have given you something like this. Limits, limit x approaching 2, modulus of x minus 2 upon x minus 2. We need to show that this is not existing. Fine. So see, in modulus problems, we need to reframe the problem in a correct way, basically. Right. So let this be f of x. This is function of x because it has terms of x, okay, something in terms of x. So this we will just rewrite in this manner: plus x minus 2 upon x minus 2. Now why am I putting a plus sign over here is because I have identified the critical point over here as 2. The critical point is 2. So if the value of x is slightly more than 2, if the value of x is slightly more than 2, let's say 2.1, so 2.1 minus 1, that is 0.1, so that's a positive answer. Okay, so we are discussing about this x. Okay, so if it is 2.01 minus 2, so its answer will be, plus 0.01. So it will be more than, uh, you know, the answer will be positive over here. Okay, when the x value is more than 2, right? What if the x value is less than 2? This is for x is more than 2. Okay, the function of x, same function of x is negative x minus 2 upon x minus 2. So this second situation is valid only when x is less than 2. Okay, so let's say 1.9. 1.9 minus 2 is negative 0.1, right? So this entire term inside will be negative when x is lesser than 2. So this is how we need to reframe first. Okay, so I have identified the critical point 2, and then accordingly I'm just writing these two cases. So the value inside the modulus is positive when x is greater than 2. Value inside the modulus is negative when x is lesser than 2, right? Now in such type of problems, we'll change our method. Okay, so whatever techniques I'll be teaching in exercise 18A, let it be restricted only for exercise 18A. Don't apply these methods for the remaining exercises of limits. Okay, go by the normal methods. So we'll try to find out the left hand side limit. Okay, now see the value 2, which is the critical point. So when I say x approaching 2, so x becomes 2 from the right hand side and from the left hand side. Okay, so for example, there is 1 over here and there is 3 over here. So the value of x will be 2 in this manner: 1.1, 1.2, 1.3, 1.9, 1.999, so on and so forth, which is approximately equal to 2. So the value of x approaches 2 from the left hand side. Okay, so the nearest value will be 1.9999999, okay, which is not exactly equal to 2, but then it is very close to 2, and we can also say it is approximately equal to 2. Now the value of x also approaches from the right hand side. So this is the left hand side and this is the right hand side. So from 3 onwards, if you reduce the value of 3, it will approach 2 from the right hand side. So it will be very near to 2, that is 2.00001, approximately equal to 2, but then still it's not exactly equal to 2, but then approximately equal to 2. Okay, so these are the two situations, right? So what we'll have to do is we'll have to find out a limit in both the cases. Okay, so first, left hand side limit is equal to limit x approaching 2 minus. 2 minus is nothing but x is approaching 2 from the left hand side. Fine, from the left hand side. Now when we say left hand side, these all values are lesser than 2. Okay, these all values are lesser than 2. Now look at this first slide. So which function should we consider? Should we consider the first function or should we consider the second function? Certainly we will consider the second function because x is less than 2. So I'll just write over here as minus of x minus 2 upon x minus 2. Minus of x minus 2 upon x minus 2. Okay, right? Now this method, again I'm telling you, just restrict only for the first exercise. So let x is equal to 2 minus h. So whenever it is left hand side limit, put minus h at the critical point. Okay, as x approaches 2. Okay, in this thing, if x is approaching 2, 2 and 2 will get cancelled, h will approach 0, h will be 0. Okay, so as the value of x becomes 2, value of h becomes 0. So left hand side limit is equal to limit h approaching 0 minus of wherever there is x, wherever there is x, put 2 minus h. Okay, minus 2 upon 2 minus h minus 2. Fine, wherever there is x, just put 2 minus h. Okay, so we'll simplify this further. Okay, minus 2 plus h minus 2. So LHL, left hand side limit, limit h approaching 0, minus 2 plus h, and then we have minus 2 over here, and down 2 minus h minus 2. Okay, 2 minus h minus 2. Fine. So down we can cancel this 2. Up we are having minus 4 plus h upon minus h. Okay, fine. So basically, I think I have made one bracket error over here. I'll just re-explain this. Just a second. Yeah. So minus of, let's write 2 minus h minus 2. It is in this way. Sorry for this. Okay. So here 2 and 2 will go. So we'll be left with plus h in the numerator. Okay. And down 2 and 2 is obviously gone. So this will be h upon minus h, that is minus 1. Okay. So the left hand side limit is minus 1. Let us go to the right hand side limit. We are calculating the right hand side limit because the value of x approaches to 2, x is approaching 2, okay, from the right hand side. Okay, so limit x approaching 2 plus 2 plus is nothing but the value of x is approaching 2 from the right hand side. So all the right hand side values are greater than 2, right? So look at the function that we are supposed to use. We'll use the first function because this is for x is greater than 2. Okay, so we'll write plus x minus 2 upon x minus 2. Fine. Let x is equal to 2 plus h. So for right hand side limit, we have to write plus h. And for the left hand side limit, write minus h. As x approaches 2, okay, h will approach 0. See, look at this. X is equal to 2 plus h. When x is 2, h will approach 0. Fine. So see, this can be further written as limit h approaching 0 plus 2 plus h minus 2 upon 2 plus h minus 2. Fine. So wherever there is x, I'm just putting 2 plus h. So 2 and 2 will go. Inside also 2 and 2 will go. So this will be limit of h approaching 0 positive h upon positive h, which is, if we cancel this, we'll get 1, and limit of a constant is constant. Now look at this. The left hand side limit is -1 and right hand side limit is 1. So this is not equal. So we can comment LHL is equal to, LH is not equal to RHL. Left hand side limit is not equal to right hand side limit. Therefore given limit does not exist. Okay. So we are starting with the second problem now. It's given that limit x approaching pi by 2 tan x. So we need to prove that this limit is not existing. Okay. Now see, x is pi by 2. Okay. So on a number line, if this is pi by 2, x can approach pi by 2 from the left hand side or the right hand side. Okay. So we'll go ahead with LHL RHL method. So LHL, limit x approaching pi by 2, and LHL is always minus, so x is less than pi by 2. Okay, tan x. Fine. So pi by 2 is over here, x is approaching pi by 2 from the left hand side, and you guys know that all left hand side values are less than x. Less than x, in this case x is pi by 2. Okay, so less than pi by 2. Fine. So we'll do one thing. Let x is equal to pi by 2 plus h, oh sorry, minus h, because it is LHL. Fine. As x approaches pi by 2, as x tends towards pi by 2, h will approach 0. So when the value of x is pi by 2, this pi by 2 and pi by 2 will get cancelled, as in, see, I'll tell you. So pi by 2 is equal to pi by 2 minus h. Pi by 2 pi by 2 will get cancelled, and minus h is equal to 0. This gives us h is equal to 0. Okay. So replace x with pi by 2 minus h. So this is equal to limit h approaching 0 tan pi by 2 minus h. Now pi by 2 is over here, 90 degrees. Minus is clockwise direction. So in this particular direction, in this particular quadrant, tan is positive, first quadrant. And since it is y-axis, pi by 2 is y-axis, so tan changes to cot h. Fine. Okay. So this is equal to cot 0. Okay. Now see, cot 0 is 1 upon tan 0. Tan 0 is 0. So this is not defined. Okay. So the left hand side limit is not defined, which is okay, which clearly tells us that the limit does not exist. But then see, LHL and RHL should not be same, or LHL and RHL both should give you not defined. Then only we can comment that the limit is not existing. So here we got LHL as not defined. We'll just test what is RHL. Irrespective of that, we can directly comment that the limit does not exist because we got LHL as infinity. So limit x approaching pi by 2 plus, pi by 2 plus indicates RHL. That means the value of x approaches pi by 2 from the right hand side, and all the right hand side values are greater than pi by 2. Fine. So this is tan x. Let x is equal to pi by 2 plus h. Why plus h? Because RHL will write, plus h over here. As x approaches pi by 2, So when x is pi by 2 over here, so pi by 2 and pi by 2 will get cancelled and h will approach 0. So limit h approaches 0, tan pi by 2 plus h. Okay. Now pi by 2 is over here, plus is in the anti-clockwise direction. Okay. So in this first quadrant, tan is negative. Okay. And y-axis, tan changes to cot, cot h. So minus cot 0. Cot 0 we know it is not defined from the previous part. So it is negative infinity. Okay. So basically you see LHL and RHL both is not defined. Both are not defined. Okay. Therefore limit does not exist. Okay. It is not like the previous problem. See what happened in the previous problem is we got RHL, LHL as minus 1. Okay. And we got RHL as 1. Okay. So in this case, LHL and RHL, LHL and RHL, this was 1 and this is minus 1. Okay. They were defined. They were well defined numbers, but then they were not equal. Hence, given limit does not exist. But then in this case, both are not defined. LHL, RHS both are not defined. So limit does not exist. Fine. Let us go to the third problem. Question number 3. The function of x is divided into two parts. X square plus 4. This is for x lesser than 2. And f of x is equal to x cube. This is for x greater than 2. This is for x greater than 2. Okay. They're asking you to find limit x approaching towards 2 f of x. Okay. Now here the function is having a critical point at 2. Okay. So when I say greater than 2, it means it can be a bigger value which is greater than 2, like 2.5, 3, 4, 5, or it can be a very very value which is very near to 2, that is 2.00000001, which is technically greater than 2 but then approximately equal to 2, right? So to find out this particular limit, x is approaching to, x approaches to indicates that x is not equal to 2, exactly not equal to 2, but then x approaches to from the left hand side and from the right hand side. So to find out this, we will try to get the limit. Okay. The limit answer from the left hand side as well as the right hand side. Now let's see what is happening over here. The left hand side limit will calculate LHL. X is approaching to 2 minus, minus indicates left hand side limit. X is approaching 2 from the left hand side. All the left hand side values of 2 are lesser than 2. Okay. F of x. Now x lesser than 2. If you take a look at the question, x lesser than 2 is this. So this will be x square plus 4. Okay. So let x is equal to 2 minus h. X is equal to 2 minus h. As x approaches 2, when x becomes 2, 2 and 2 is gone, h becomes 0. Fine. Okay. So, and when to apply this h method, you guys apply only in exercise 18a. So this is 2 minus h the whole square plus 4. Put the value of h as 0. So this will be 2 minus 0 the whole square plus 4. So 4 square plus 4. 2 square, that is 4 plus 4. Answer is 8. Answer is 8. Okay. RHL, limit x approaching 2 plus. 2 plus is RHL. The value of x approaches 2 from the right hand side. So right hand side values of x are certainly more than 2. F of x. So this is equal to limit x approaching towards 2. 1 second. So x greater than 2. When I say x greater than 2, it is x cube, right? So f of x, I'll just write it as x cube. Okay. Let x is equal to 2 plus h. Okay. X is equal to 2 plus h. As x approaches 2, h will approach 0. So when x is 2, 2 and 2 is getting cancelled, h will approach 0. Okay, so this will be limit f h approaches 0, 2 plus h. Wherever there is x, put 2 plus h, the whole cube. So 2 plus 0, the whole cube. 2 cube, which is equal to 8. See here, LHL equal to RHL equal to 8. So the value of the limit exists. It is existing because LHL and RHL are both well-defined numbers and both are equal. That is 8. So the answer for this particular problem is 8. Fine. Let us go to the fourth problem, question number 4. Okay. F of x upon modulus of x. This is when x is not equal to 0. Okay. And f of x is equal to 0. Okay. When x is equal to 0. Now modulus problem will try to reframe this. F of x can take three values. First value is 0 when x is equal to 0. It's given to us. This is given to us. Now x upon plus x. Inside value is positive when x is greater than 0. Inside value is negative when x is lesser than 0. So this is 1 and this is minus 1. Okay. 1 and minus 1. Right? Okay. So we are supposed to find out limit x approaching 0 f of x. Right? Now see, we have to find out left hand side limit and right hand side limit. First we'll do that because x can approach 0. See, they're asking limit x approaching 0 f of x. So x approaches 0 from the left hand side or the right hand side. So LHL limit x approaching 0 minus. 0 minus indicates left hand side limit. Here x is lesser than 0 f of x. Okay. X lesser than 0. X lesser than 0 is this. So the answer is here minus 1. Fine. So here it is minus 1. So limit of a constant is a constant. We all know that. Okay. RHL limit x approaches 0 plus x is greater than 0. Okay. Plus 1. X greater than 0 is plus 1. Fine. So limit of a constant is constant. Okay. So LHL is minus 1. RHL is 1. So LHL not equal to RHL. Okay. So in this case, this particular limit of this particular function will not exist. Okay, so they're asking us to find out the value of this. Okay, what is the value of this? But then we'll comment that it does not exist because LHL is not equal to RHL. Fine. Okay, let us go to question number 5. Question number 5. F of x is equal to x when x is less than 0. F of x is equal to 0 when x is equal to 0. F of x is equal to x square when x is greater than 0. So they are asking you this. limit x approaching towards 0 f of x. Okay, now x approaches 0 from the left hand side and from the right hand side. So for the left hand side, we'll calculate the left hand side limit. For the right hand side, we'll calculate the right hand side limit. Okay, so left hand side limit LHL limit x approaching 0 minus 0 minus is left hand side limit LHL, sorry. So x approaches 0 from the left hand side. Okay, so x is lesser than 0, right? And x lesser than 0, the function which we are supposed to take is x. So this is x over here. So since we are having x, it's not a constant. So let us write x is equal to 0 minus h. Okay, as x approaches 0, so when x is 0, 0 and 0 gets cancelled, h will approach 0. Okay, so limit h approaches 0, 0 minus h. So that is 0 minus 0. The answer is 0. So we got the LHL as 0 over here. Okay, we'll try and calculate the RHL over here. RHL limit x approaching 0 plus x is greater than 0. 0 plus indicates RHL. RHL meaning is right hand side limit x approaches the value 0 from the right hand side. Okay, f of x, right? But then f of x will replace with the value which is greater than 0. Okay, greater than 0 is this, so we'll write x square over here. Fine. Okay, so let x is equal to 0 plus h as x approaches 0. So when x is 0, 0 and 0 is gone, h will also approach 0. So this is equal to limit h approaches 0, 0 square, which is 0. Now LHL is equal to RHL and both are equal to 0. Therefore, the limit exists. The limit exists and is well defined and it is equal LHL RHL. Okay, so the answer is 0 over here. The value of the limit is 0. Okay, then let us proceed with the next problem. Question number 6. They're asking you whether limit x approaching 0, 1 by x, it is existing or not. So x is approaching 0 from the left hand side and from the right hand side. So for the left hand side, we are having left hand side limit x approaching 0 minus, so x lesser than 0, the values of x will be lesser than 0 over here. The values of x are approaching 0 from the left hand side. 1 by x is equal to, let us say, 0 minus h. This is 0 minus h over here. Okay, as x approaches 0, as x is 0, so h will approach 0 as well. Okay, so limit h approaching 0, 1 upon 0 minus h, 1 upon 0 minus 0. So this is not defined. We have got LHL as not defined over here. Okay, right? So RHL in this case, RHL in this case will also be not defined. Fine, you can check it out on your own. So LHL is not defined. Definitely RHL has to be not defined and hence the limit does not exist over here. Fine. Okay. Then the seventh question, we need to prove that limit x approaching 0 e raised to minus 1 upon x is not existing. So value of x is 0 from the left hand side, from the right hand side it approaches 0, from the left, from the right. So we'll find out the left hand side limit as well as the right hand side limit. So 0 minus indicates left hand side limit, the values of x are approaching 0 from the left hand side. Okay, f of x, is nothing but e raised to minus 1 by x. Let x is equal to 0 minus h, 0 minus h. We are changing the limits over here. Okay, as x approaches 0, as x approaches 0, 0 and 0 is gone, h will also approach 0. So limit h approaches 0, minus 1 upon 0 minus h. Okay, so this is e raised to minus 1 upon 0 minus 0. So e raised to 1 upon 0 is not defined. So minus 1 upon 0 is also not defined. E raised to infinity. We are getting this as e raised to infinity, which is also equal to infinity. Okay, not defined. So LHL is not defined. So certainly we'll get the RHS as not defined. Okay, fine. So this is how it is. Okay, so in this case also the limit will not exist. Fine. Let us go to question number 10 from the same exercise. Question number 10. Okay, so we are supposed to find out the values of p if the limit is existing. They are saying this is given up. We need not prove this. This is existing. This is given to us. Okay, f of x is equal to 2px plus 3, and f of x is equal to 1 minus px square. The first one is x lesser than 1, the second one is x greater than 1. Okay, so the limit exists. So if the limit exists, LHL is equal to RHL. We need not prove this. We'll take it as a condition. So LHL is equal to RHL. So I'll just write what is LHL. LHL, limit x approaching 1 minus 1 minus x lesser than 1. Okay, x lesser than 1. So this function 2px plus 3, we'll take 2px plus 3. Okay, let x is equal to 0 minus h, sorry, 1 minus h. Okay, as x becomes 1, as x is 1, h will become 0. Okay, so limit h approaching 0, 2p into 1 minus h plus 3, which is 2p into 1 minus 0 plus 3. The value of h is 0. So this is equal to 2p plus 3. The LHL is 2p plus 3. Let us understand what is the RHL. RHL, limit x approaching 1 plus. That means the value of x is near to 1 or approaching 1 from the right hand side. Okay, so it's 1 plus. That means all the right hand side values are greater than 1. F of x. Okay, so f of x is what? F of x is greater than 1. So f of x is 1 minus p square. So this is 1 minus px square. 1 minus px square. Fine. Now let x is equal to 1 plus h. Since it is RHL, we'll take 1 plus h. In the LHL, we took 1 minus h. Okay. So as x approaches 1, as x becomes 1, h will approach 0. So this is equal to limit h approaches 0, 1 minus p. Okay, 1 plus h the whole square. Fine. So this is 1 minus p, 1 plus 0 the whole square, which is equal to 1 minus p. Okay. Now since we know LHL equal to RHL, LHL equal to RHL. We did not prove this, it is given. Limit is existing, so LHL will be equal to RHL. Fine. LHL will be equal to RHL. So 2p plus 3 equal to 1 minus p. So 2p minus p is equal to 1 minus 3, p equal to minus 2. Okay, I think just a second. 2p plus p. So this is plus p and this is minus 2 by 3. Sorry for that. Okay, so this was all about exercise 18a, the left hand side limit, the right hand side limit. Okay, so this particular concept you make it applicable only while solving exercise 18a. For the rest of the exercises it is not really required. Fine, thank you.